Unit 9, Circles Part 1. Find the following terms. These are going to be very basic, abbreviated definitions. Minor arcs are less than 180 degrees, such as BA, BD, ED, FD, AF. All those are minor arcs. A radius is a line that goes from the center to the edge of a circle. So CE, and notice that is a line segment. Also CD and CA would also be radii. A semicircle that's 180 degrees, such as AFD. You could also call it AED, or DFA, or DEA. A chord connects 2 points on a circle not through the center. A major arc is more than 180. And the diameter connects 2 points on circle through the center. Oh, I forgot to put something. So a chord would be like BF. And a major arc would be BFD or BED. Head. And diameter would be AD or DA. Okay, a tangent is a line. A horribly drawn tangent. It's a line that just touches a circle at one point. Secant is a line that intersects a circle at 2 points. Okay. Converting to radians, we want pi in the answer, so pi is going to go on top. And basically, you're going to divide by 180 and multiply by pi. So all you're doing here is reducing that fraction of 240 over 180. And it reduces down, you could reduce first to 24 over 18, divide by 10, and then divide by 6, 4/3 pi. Same thing here, 30 over 180, that's pi. So 3/18, 1/6 pi. Now, to degrees, we're trying to get rid of the pi. So pi is going to go down here, and 180 is going to go on top. That way our pi's cancel. Now you can just type this in your calculator, 11 times 180 divided by 6, or just know that 6 goes into 180 30 times, and 30 times 11 is 330 degrees. 3 halves pi, pi on the bottom, 180 on top, cancel. 2 goes into 180 90 times, and 3 times 90 is 270. Okay, arc length and sect area of a sector. Both of these are going to do 150 over 360. because it's that portion of the circle. Now remember, for circumference is pi times diameter. So you're actually going to multiply 150 over 360 times that formula to get this piece right here. Because circumference is all the way around. And if we multiply the whole circumference by just the 150 over 360, we get just that section right there. So pi, and it says leave your answers in terms of pi, times the diameter, which is 22. And if we reduce that, it ends up being 55 over 6 pi inches. And then for area, remember, area of a circle is pi r squared. So we're just going to take that 150 times 360 times pi 11 squared, which is 121. And that is going to reduce to 605 over 12 pi inches squared. Same idea over here, except this time we're doing 300 over 360 twice. Once with pi times diameter, and once with pi times radius squared. Well, the arc length breaks down to 10 pi kilometers, and the area breaks down to 30 pi kilometers squared. Okay, find the area of the shaded region. Leave your answers in terms of pi. Well, if 14 is the diameter and 150, that means this is 30. So if we just do 30 over 360 times pi 7 squared, because the diameter is 14, radius is 7. That simplifies down to 44/12 pi centimeter squared. Now, there's two ways to do this, and they're basically the same. If you look at this and think that 75% or 3/4 of the circle is shaded, then you just do 3/4 of pi r squared, which ends up being 27 pi centimeters squared. The technical way is, this is 275 degrees out of 360. Guess what it reduces to? 3/4. Okay. We gotta find the big and the small. We also gotta be careful, because it says the radius of the big one is 30. So area equals 3.14 times r squared. And then it says the diameter of the inside is 10, which means the radius is 5. Most common mistake would be to use the 10 there. Pay attention to the details. Area equals 3.14 times 5 squared. Well, this ends up being 2826, and this is 75.36. When you subtract them, you get a 2750.64 square inches. So just be very careful and go slowly. Don't be in a rush. Pay attention to the details. Okay. Whenever you have a situation where you have a tangent, U2, meeting chord or secant like this, this angle is going to be half of that arc length. Arc measurement, I mean. So if that measurement is 120, then our angle is 60 degrees. This one's very similar, except this is 220 over here. We need to do 360 minus 220 to get 140. And then half of that, 70 degrees. All right. So we don't know the big arc. We know the small arc, and we know the angle measurement. So remember, it's the big arc minus small arc divided by 2 is equal to the angle. So you need to multiply by 2. That gives me x minus 48 equals 120. Add 48 to both sides. 168 degrees. Similar problem, big arc minus the small arc. Divided by 2 equals 65. Well, if we multiply by 2, we get 198 minus x equals 130. Let's subtract 130 and move the x over. So x equals 68. All right, next one. In this case, when the lines are crossing inside, you do 58 plus 88 divided by 2. And that gives you 73 degrees. Similar problem here. 105 plus the unknown divided by 2 is 107. Multiply by 2. 105 plus x equals 214. X equals 109. All right. So remember, always total up a line like this, 15. Because remember, it's the outside times the whole equals tangent squared. So x squared equals 90. Square root both sides. X is approximately 9.49. All right, tangent meets the radius at 90 degrees right there, which makes this the hypotenuse, which means you have 6 squared plus 8 squared equals c squared. So 36 plus 64 equals c squared. C squared is 100, square root both sides, and c is 10. So this is 10. Well, this is the radius, which is 6. This is the radius, which is 6, which makes our question mark 4. All right. AC is 20, which makes this 10. OD is 24. We're trying to find OB, which is the radius, same as AO. Right angle, 10 squared plus 24 squared equals c squared. C ends up being 26. 24 squared plus 100, square root that number, you get 26. So OB is 26. Right, AC is 30, which makes this 15. OB is 25, which means this is 25. Right angle, 15 squared plus B squared this time equals 25 squared. So 225 plus B squared equals 625. B squared equals 400. Square root of both sides, and B equals 20. Therefore, OD is 20. Twelve times x equals 14 times 18. So 12x equals 252. X is 21. 15 times x plus 4, in parentheses, careful, equals 24 times x minus 2, in parentheses, be careful, $15x plus 60 equals 24x minus 48. Subtract 15x, you get 9x. Add 48, you get 108. Divide by 9, x is 12. We need to find the diameter. 8 squared plus 9 squared equals c squared. AC is 12.04. 81 plus 64, square root, 12.04. Which means OC, or the radius, is 6.02. The circumference is pi times diameter. Which is 37.81 feet. And the area is pi r squared, which is 113.79 square feet. This one says leave in terms of pi. That one said round nearest 100. So we have a 30, which means this is the short side. So that's easy because that makes the long side, the hypotenuse, just double. Which means the radius is 10. So the circumference is just pi times diameter. And the area is radius squared, 10 squared is 100, pi, centimeters, meters squared. Okay, quadrilateral ABCD. AB is 12. BC is 16. CD is 10. The rule is BC plus AD equals BA plus CD. Basically opposite sides. So 16 plus x equals 12 plus 10. So 16 plus x equals 22, x equals 6. So AD is 6. Alright, all these are tangents. CH is 4, which makes CK 4. CA is 15. Well, if this is 15, and CK is 4, that makes this 11, which makes this 11. Because the tangents coming from the same point are equal. And BH is 8, which makes this 8. So it says find AB, 11 plus 8. AB is 19. Now all this information right here goes on the next page for 35. So, it says, and it goes nice and slow on this. It says, OF is 10. That's 10 right here. AOB is 20. Angle AOB is 20, which makes this 20 also. GF is 6. This little bad boy down there is 6. AH is 50. BC is 60. Find the missing measurements. Well, before I even look over to the right, I'm going to fill a bunch of stuff in. Notice that HD is a semicircle. Therefore, this is 180. Well, I already have 50 plus 20, which is 70, plus 60, which is 130, which then makes this 50. All right? Now, if you notice, if you look carefully, this is 70 right here, correct? Well, notice this is formed by these two lines, which makes this a vertical angle there, which makes this piece 70. So now we have 70 plus 6 is 76, which makes this 104. Now we have all the parts of the circle outlined. So let's see what we got. AB, we know is 20. I'm going to do all the arcs first. CD is 50. DF is 70. HG, well, that's all the way around except for the 104. So I'm just going to do 360 minus, I'm sorry, HG is the other way, 104. I totally overcomplicated that. I was doing the major arc, HCG, not the minor arc. Silly mistake. That I made on purpose just for you to pay attention to. All right. That's it on arcs. Okay? So I am going to get rid of a bunch of this. Oops, I'll rewrite that 20 in there. Okay, now CKD. CKD. Well, we have a chord that intersects a radius or a diameter, which makes this 90 degrees. ODE. ODE. Again, a tangent intersects with the radius at 90 degrees. HOF. HOF. F. That is everything except the 104 and the 6. So it's basically 360 minus 110. Oh, sorry. I'm done with arcs, aren't I? HOF is inside HOF. So that's 104 plus 6. So that's 110. I'm doing angles. Gotta pay attention. I'm doing angles. BFC. BFC. Well, this is 60 degrees right here. But since this is an inscribed angle, we do half of it, which is 30. AEB. AEB. Okay? So it's the big minus the small divided by 2 equals 7. BED. BED. So that's going to be the big arc, 110, minus the small arc, which you said was 70, divided by 2. That's 40 divided by 2, which is 20. Now the length of CD. Well, CD is 50. So it's 50 divided by 360 times pi times diameter. And the diameter is 20. That's 8.72. The length of HG. Well, HG is 104. So 104 over 360 times 3.14 times 20 is 18. Whoops. 0.14. Okay, circle fill out first. So QI is the diameter, which means it's 180 degrees. So if this is 140, this makes 40, 180. This is also 180. So 60 and 40 is 100, which makes this 80. And this is vertical to the other 40, so there we go. Now we can analyze. QU. All right, I'm going to do all the arcs first. 40. IUK, which means major arc. I to the U to the K. If I can add up 140 plus 40 plus 80, or do 360 minus 100. 260. KCU. KCU. Again, I can do 60 plus 40 plus 140, or 360 minus 120. Makes no difference. It's 240 degrees. QC is 80 plus 60, which is 140. CI, 40. And now time for some angles. QLC. QLC is a central angle, which is 140, 80 plus 60. KIU. KIU. K to the I to the U. Well, that's 120 degrees. Then we have to take half of it because it's an inscribed angle. 60. KUI, which is on here twice. KUI. Well, that's right here. 100 degrees divided by 2. It's an inscribed angle. 50. QLU. QLU is a central angle. 40. ILQ. ILQ straight across. 180. And last, CQI. CQI. 40 degrees right here, so half of that is 20. Hey, that was the end of that part.